Good morning. I'm Władek Grabiński, and I will talk about compact and spice modeling and its support for TCAT and TDA tools. All previous speakers were referring to compact and spice modeling. Last question by Javier was also about Verilog, a standardization for compact modeling. So this is a quite important part of communication, information exchange between different tools. Myself, I'm also coordinating Mosaic group. This is a group which mainly discuss compact and spice modeling, model implementation, standardization, and transistor level simulation. We are organizing workshops to discuss these topics. I will give you an update on our event we are planning for later this year. I will start with Moore's law, talking about microelectronics, semiconductor devices. You cannot open a presentation without a short reference to Moore's law. Then I will go through simulation and modeling flow to show you process and TCAT simulation, compact modeling, model standardization, model implementation. There is important part which we are not addressing today. It's parameter extraction and library generation to interact between models or technology models and analog simulation. And then there's reference to analog RF, mainly analog RF simulators, referring to both Quarks and ngSpice, giving example of other tools. On each point, I would like to arise or open question about interoperability, Verilog's standardization, just to smooth out the communication, information exchange between different tools. I guess all who are in microelectronics, semiconductor devices, circuit simulation, they already know this plot. Back in 60s, Mr. Moore make a conclusion that density of or number of transistors per chips basically double every two years. In fact, I don't like this observation because Mr. Moore and his partners at Intel, they use this law to create Intel domination of IC manufacturing. But there is a positive element of Moore's law. The very first integrated circuit was developed by Fairchild. This is data about my birthday, so do not estimate my age. But then very quickly over the last almost 5 decades, from few integrated transistors on one chip, we came to circuits which allow to build extremely cheap hardware. Well, I'm referring to this because hardware is so cheap that we can have basically any software running almost for free on this type of devices. And I guess all the FOSS community benefits on this very cheap hardware, developing their own tools. Today, we, in this, I guess, very first session of TCAT tools at FOSDEM, I want to go through this chain. We as researchers or engineers, we cannot really manufacture integrated circuits, but we can contribute to process and technology optimization using TCAT tools. Paulo was referring to Cogenda. It's very sophisticated 2D, 3D process and technology simulation tools. There are DevSims, also numerical modeling tools. There is a long list. Francesco was referring to other tools. Then this is input for compact modeling. You can develop outstanding simulation tools, but without models, it's just numerical solver. You need the models to simulate your circuits. We review ngSpice Quarks, but there are a couple of other simulation tools, and I guess this list is quite long. For compact modeling, both speakers were referring to SPICE, Verilog simulation, model generation. There are other tools which are supporting this. A lot of attention was paid to ADMS. I guess this is one of the only tools to support this transition from technology to develop compact models and then support simulation tools. More recent, but it's like benchmarking platform, it's IMOS, was also mentioned here. MAP, it's new development triggered by nanohub.org in US. Again, we are talking about models, but we need the parameters to run the simulation. This part is not covered here, but it's important, and we should find a moment to discuss maybe on following meetings, workshops, or this type of conferences. Process simulation. Again, we cannot fabricate. It's quite complex, but we can support device development, technology optimization. This is an example of 3D simulation of SRAM cell using Cogenda TCAD tools. It's a free GPL software. You can do quite complex, sophisticated simulations. DevSim is another example. This is a 2D simulation of MOSFET device, and you can see the current flow and mobility distribution in this particle device. These two tools give you input for compact modeling to build your models. What is a compact model? So it's a representation of semiconductor devices, its charges, current, and voltages. We trying to go from very complex numerical simulation to simple analytical representation to preserve also device physics. In terms of accuracy, TCAD tools, these two tools I already mentioned, there is, of course, huge development of commercial tools. They provide high accuracy, but they are very slow because you have to solve 2D grid to calculate device charges, current, and voltages. Compact models are much simpler because we are trying to develop a simpler equation which gives you or predict the behavior of your device. And it's analytical, couple of lines of code. It's much faster. Speed up is enormous. Then, of course, you cannot use compact models, analytical models for gate level simulation because simple CPU, a billion transistors, you cannot simulate a billion transistors of your CPU or memory cell at this level. So you go to transistor level, but you need compact models to create, for example, timing libraries to run digital simulation. We are not covering this topic here, and I guess both tools, Quarks and ngSpice, are not on this level, but they allow behavioral simulation of Verilog digital blocks or VHD digital blocks. So we have FOSS tools also for this level. It's huge circuits and very fast simulation. Now coming to SPICE Verilog compact modeling and simulation. This book on analog behavior modeling with the Verilog language, it's about, I guess, 97. And already at that time, there was first push for standardization. Believe it or not, if you borrow this book from library, you will find floppy. I don't know if you remember what is floppy. And it's complete simulator, SPICE simulator with Verilog extension allows you basic semiconductor device modeling with Verilog. Go to library, fetch, you will be surprised. I don't know if you can run or read the files from floppy, but I did it and it works. There was next attempt, I guess it's about 2000 by guys from University Arkansas. They built, oh, it's already 1 minute. Other model generator. This similar attempt was done by guys from Tiburon. They simplify, they create compact model libraries which talk to real-time interface of different tools. They simplify model synthesis and communication with SPICE. This tool was already referred. I will not repeat, but at least in my opinion, it's the only open source tool supports Verilog standardization. iPlatform was already referred. You can double check references. And map tool still use MATLAB, but they are going to Octave. So this development environment will be also based on free tools. Benefits. I think I need half a minute here. If we all agree and accept Verilog A or Verilog AMS as a standard for compact model, this will be beneficial to all who are within this activities. So for model developers, for software vendors, or in fact FOSS development, ngSpice, Quarks, and other teams, we can also interact with wafer fab and support designers, users of our tools. I will skip this. ngSpice and Quarks was presented. Ikes from Sandia Lab also use Verilog standardization, and they did their own modification to ADMS translator. So we can exchange models. So having one model, this model go to all the tools. GNU-CAP, we do not have presentation. I'm not a GNU-CAP user, but seems to be, it's a really nice concept, modular, basing on different plugins. And there is a group of plugins also supporting ADMS compilation, device models, and they have their own generator, which depends on Verilog. So Verilog is like communication means. I'm almost at the end. So again, to go through process simulation modeling to compact modeling, we need interoperability. We need common data exchange format to talk from process simulation to support compact model development. We need Verilog standardization to enable model implementation into simulation tools. Here we have a bunch of simulation tools. ngSpice, it has very fast transient simulation, but does not support harmonic balance, which is excellent feature of Quarks. So to communicate, we need, again, interoperability at netlist and schematic. These points were addressed in both presentations, and I want to highlight. So we need a lot of work on standardization to improve information exchange between all the simulation tools which we are using. This is a final slide. You can read. There is a series of events where we discuss compact modeling, standardization on different occasions. Very first, it's in Grenoble at date. You can visit mosaic8.org to learn more. And we will continue this discussion because it's critical to have a smooth interoperability at different level of FOSS tools, in particular for integrated circuit simulation. Thank you very much. The question was about Verilog A standardization for schematics. This is a very important question, but we do not have a solution. There was discussion to use this type of high-level behavioral languages to describe not only devices, but schematics or netlist. ngSpice use very, I cannot, I don't want to say old, but standard Spice input language, which is a little bit outdated. Quarks has its own. So there is open discussion also within industry to have more flexible input formats for netlist and schematics. And very likely Verilog could be a solution. But yes, please. Again? The comment was that GNU-CAP reads netlist. I'm not the GNU-CAP user, but yes, it's very flexible tool, and Al Davis does a lot of work in this kind of standardization to simplify information exchange also at the netlist. Thank you.